the work we've done is actually with a medical linear accelerator called LINAC. We were the first to have a LINAC with a CT in the early 2000s. Connecting an MR and a LINAC is very complicated. We were the first to merge these together. We want to see the tumor at the time that we are irradiating. But it was considered impossible to merge the LINAC with an MR. We actually had to design major changes in engineering and physics, understand the problems between these two machines. And in our first prototype, we were the first in the world to successfully merge an MRI with the LINAC. In other words, make one machine that functions as an MR and a linear accelerator working at the same time. The main one was, in addition to this engineering and science, the one that we had lots of difficulty with was getting funding from this type of research because it was extremely novel. So we had to prove different aspects of this, which we did. 2008, everything was working perfectly. From then on, everybody knew that this technology would work. I must thank the Alberta Cancer Foundation, who gave us a small grant to start to prove this feasibility. And later on, we were able to get other grants matching, both for the Alberta Cancer Foundation, for Alberta Innovates Health Solutions, for Western Economic Diversification, and also from the Alberta Government, Trade and Development to make this through. Also, we thank other national agencies such as CIHR and INSERT that helped us develop different aspects of this technology. That was from elsewhere, and Alberta then had a great infrastructure through was then the Alberta Cancer Board. But the seed was made, so we thank Alberta and the Alberta funders who allowed us to do this. Right now, it's a major push in our field. Well, it's like all children. They go to high school, university, they like either science, engineering, arts, or medicine. And this was a good way to merge physics and math in the medical world. So actually using all these techniques to help people. It's a very fascinating field. In our particular system now, we are implementing various machines. We have a vault, we have a research vault at the Cross Cancer Institute, another one, a clinical vault being built as we speak to put the modern version of this machine. And once we clear regulatory, such as Health Canada and FDA, to use as a medical device on patients, we hope to initiate a whole series of clinical studies on the use of this machine. The only way we can use the machine elsewhere, say even elsewhere in Alberta, elsewhere in Canada or Europe, is to commercialize it. And that commercial entity happens to be MagnetTx Oncology Solutions. So they are the commercial entity to commercialize this technology. We're very proud to be chosen among all the other excellent proposals. We did it, and we're happy, and we're very proud that ASTech has decided to look at us.